Okay, so before we had done simplifying radicals, and we went ahead and we did examples like this where we were taking something out of 27, we had broken it down, found the pairs, and we said this is 3 square roots of 3. We continued on using variables. We continued on if there was a number out front. We looked at what if it was a cubed root. Well, then we were looking for triplets. And then we went ahead and we talked about what if you wanted to multiply radicals. So if you're multiplying radicals, we said you could put those radicals both under the same radical and then go ahead and break it down and simplify the problem. Today what we're going to do is we are going to look at what if you're adding or subtracting those. And when we do this, we want to think of it like we think of like terms with the x squareds or x's. And if I have 3x squared minus 5x squared, that gives me negative 2x squared. I took the two numbers out front. I went ahead and dealt with those, leaving the x squared alone, and that's my answer. Well, the same is true if I have radicals. I have 3 square roots of 2 and 2 square roots of 2, so taking the two numbers out front and combining them gives me 5 square roots of 2. If I look at the next example, we have 4 square roots of 7 and a square root of 3 and another square root of 3. The only two that you can combine are the square roots of 3 because they are like terms. So this 4 square roots of 7 just stays as is, and then I will go ahead and take negative 1 square root of 3 plus 5 square root of 3, giving me a positive 4 square root of 3. And that problem's done. If I look at a problem like the top one here, the square root of 18 plus the square root of 8, and what's underneath the radical is not the same, what I can do is check to see, can I maybe simplify it? Well, the square root of 18, we've learned you can break it down. You get a pair of 3's. Square root of 18 is actually 3 square roots of 2. Doing the exact same thing with the square root of 8. Breaking down 8, I get 3 2's. A pair of 2's. So that would be 2 square roots of 2. And combining those two together gives me 5 square roots of 2. Okay, so then the next example, I have the square root of 75 plus the square root of 12. Same thing. Break down the 75 and I get 5 times 5 times 3. A pair of 5's, so that comes out, leaving me with 5 square roots of 3. I take the square root of 12, which is 2 times 2 times 3. Take out that pair of 2's, so that would be 2 square roots of 3, for a final answer of 7 square roots of 3. Okay, looking at this next example, I see I have 2 that have cubed roots and 1 that has a square root because there's no 3 in front of there. Well, the only 2 that I could possibly combine together are the first 2. This last one, even if I could simplify it to be something that might seem to work, it doesn't have a little 3 on there, so that does not combine with the other 2. It has to be a like with it. This one here, the 10 cubed root of 2, well, that doesn't simplify any further because I can't break down 2. The 54, if I break down 54, I get 3 times 3 times 3 times 2. And because we're talking cubed root, then I can go ahead and look for triplets. That 3 comes out. It gets multiplied by the 4 to give me 12 cubed root of 2. So I have 12 cubed root of 2 minus 10 cubed root of 2, which would be 2 cubed roots of 2. Plus that square root of 2 that, again, didn't combine. So that would be my final answer. Okay, you have already completed the front side of the 6-1A worksheet. I'd like you to go ahead and complete the back side of the 6-1A worksheet. Remember, if you do not have it, there is a PDF attached on Schoology. You can go ahead and print it off or just put it on your own notebook paper.